Okay, welcome to the EE 2950 Fall 2020 Quiz 1 solution. I'm going to work through it for you real quick, just so you can get an idea. All right. So our question here asks us, the current through a given circuit element is given by this current equation, and they want us to determine the net charge that passes through the element on the time interval 2 to 8 seconds. Okay. So let's start with what we know. So we know that I of t is just the time rate difference of charge. So therefore, if we were to go and rearrange this equation, we would get dq is equal to I of t dt. And if we go and integrate both sides, we will get q is equal to I of t dt. Okay, so now what we need to do is we need to go and sub in our interval. So from 2 seconds to 8 seconds, I of t dt, which is just equal to 8. We'll go 350 t minus 40 dt. Okay, so what we need to do now is go and integrate. So when we do that, we're going to get q is equal to 350 over 2 times t squared minus 40t. Okay, and this is from 2 to 8. So we need to go in here and we need to sub in. So we will do 350 over 2. We can do 8 squared minus 2 squared minus 40 times 8 minus 2. And let's not forget that this is milliamps here, which is going to be equal to times 10 to the negative third. So when we do that, this will give us 10 to the negative third. Let's go ahead and bring it down a little bit. So this will be equal to 10 to the negative third uh, 175. 8 squared minus 2 squared will give us 60. We'll do minus 40. And 8 minus 2 will give us 6. And if we multiply out, we will find that Q is equal to 10.3 coulombs, which is our answer. Okay, so then let's scroll down to the next question. So the next question here is asking us, in this circuit given below with all of these values, find dA. So dA, so this is point D, this is point A up here, and they have drawn a few things for us in the circuit. They assigned all the terminals, and they gave us a current right there. So the first thing that we're going to need to do is look at what we have setup wise. We see that we have 2 voltage sources and 3 resistors. Okay, but we notice that this is in a loop. So that can be pretty useful to us. So let's say, scroll up a little bit here, sum of V is equal to 0. And when we do that, let's walk the circuit first. We'll do the voltage way first. So we will pick a point and we'll walk around our circuit, and whatever terminal we hit, that's the value we'll assign to it. So let's go ahead and assign, we'll start at point E and we'll walk our way around. So we'll hit negative V1, we'll come up and we'll hit plus VR1 plus VR2 plus V of 2 and plus VR of 3. And that'll give us equal to 0. Okay, but we don't know what the voltages are across any of these resistors. Oops, that's a battery. Across these resistors. So what we can say is, by Ohm's law, V is equal to IR. We can go in and replace those. So let's say negative V1 plus resistance 1 times I. I is just the current that's running through it, plus R2 times I plus V2 plus R3 times I is equal to 0. Okay. So if we rearrange this, we can do I times R1 plus R2 plus R3 is equal to V of 1 minus V of 2. So therefore, the current is going to be equal to V of 1 minus V of 2 over R1 plus R2 plus R3. And if we go and drop those in, let's see, this will be 10 minus 30 over, that's volts, over 2 plus 5 plus 10. This is ohms. So therefore, our I that runs through this circuit is going to be and apologies, this is 1, not 10. Negative 2.5 amps. Okay, so we now know the current that runs through the circuit. And now what we can do is we can go back through and do the same process where we sum the voltage is equal to 0. And now what we'll do is we'll call VDA an actual point. So what does that look like? So we can say plus VDA plus VR1 plus VR2 plus V of 2 is equal to 0. What does that look like? All we did is we made our new circuit VDA. Okay, this is R1, R2, V2. Okay, and all we did is we took point A and D and slid them down to encompass that entire bottom part. Just squished it into one point. And all we did was just walk the loop again. Plus, minus, plus, minus, plus, minus. Okay. So therefore, we can come through and very similar to what we did before, we don't know VR1, so we can just say I R1 plus I R2 plus V of 2 is equal to 0. So therefore, VDA is equal to minus V2 minus I R1 plus R2, which would give us minus 30 minus negative 2.5 amps. 2 plus 5 ohms, so volts. And this would give us a value of VDA equal to 12.5 volts, and it's going to be negative. Okay, so that's all we did is just take those 2 points, squish them down, and made another point. All right, thank you for watching.